Okay, so today's problem is called Beeramide. Let's pretend your company just hired your friend from college and paid you a referral bonus. Awesome. To celebrate, you're taking your team out to the terrible dive bar next door and using the referral bonus to buy and build the largest three-dimensional beer can pyramid you can. And then probably drink those beers because let's pretend it's Friday too. A beer can pyramid will square the number of cans in each level. One can in the top level, four in the second, nine in the next, 16, 25. Complete the pyramid function to return a number of complete levels of beer can pyramids you can make, given the parameters of your referral bonus and the price of a beer can. For an example, a pyramid with a 1,500 referral bonus and $2 price of beer can return 12. Okay, I think this one should be pretty straightforward. As always, I like to start by saying and writing down in words, writing out in comments the steps I would take in the code in order to solve this problem. So I don't start by coding. Just start by thinking about it. So we have a function that's taking in bonus and price. We know that we're determining the levels by square root. Okay. So this is mathy, which is not a real word, but okay. So let's say, first thing we want to do, we want to look at I was thinking we need to look at how many cans you can buy with the bonus first. Okay, figure out how many cans you can buy. Cans you can buy with the bonus. And then with that number, we can say, well, okay, so now I'm trying to go from that number of cans you can buy to how many levels you can have. All right, so sometimes when I'm trying to work out a problem, I just look at an example and kind of like work backwards. So they're saying that $1,500 in referral bonus with $2 beer cans can get you 12 levels. So let me pull up calculator. Okay, so 1,500 divided by 2 is 750 cans. So from that number, that netted 12 rows. Okay, so 12 times 12 is 144. I need that. So I think at this point we're looking at a factorial. I have to refresh my memory of a factorial. But I believe a factorial is basically, if you have the number 4, factorial 4 is going to do 1 squared times 2 squared times 3 squared times 4 squared. I think that's how that works. And I think we'll need something like that. So let me look up factorial. Factorial. Let's see if that's the word. Okay. So yeah. Okay, so it's 4 times 3. Oh, okay. So it's not actually doing anything with the exponents. Okay. Okay, so this is not adding up to what we needed to. Okay, so maybe it's not factorial. Okay, figure out how many cans you can buy with the bonus. So in this case, they were able to buy 750 cans. Okay, so how many levels? So just thinking through the logic. The first level, you can have one can. Okay, so can you add another level? So we know if you have one can, you can have one. If you have Okay, so this is actually getting kind of complicated because you need to be able to check with each level if you can create a new level. So you have to compare how many cans you have left in addition to all of the cans you've already used. Okay. All right, let's just give it a go. So figure out how many cans you can buy with the bonus, and then I want to do some sort of loop to determine if you can build additional levels. So what I mean by that, that loop, you're going to, the first part is determining how many cans for the current level. Determine how many cans for the current level. So with level 1, you need 1 can. With level 2, you need 4. So that is just squaring the current level by itself. Then you need to say, do you have enough cans? Do you have enough cans left to do it? Okay, so maybe I can subtract. Okay, so if so, remove the number of cans remaining down. So, okay, so instead of trying to keep track of adding all of the cans in previous levels and keeping track of that, I think I'm going to start with the total number of cans you can buy minus the current level. So when you get to that second level, you no longer have the total amount. You have the total amount minus 1 because that first level took up 1 can. Then on the second level, you have you need 4 cans. So then it would be the remainder from the end of the previous level minus the 4 cans. That number would go on to the next level. Okay. And then if you do not have enough cans, if you do not have enough cans, return current, we're going to need some sort of index. Return the index. Okay. And the index, code indexes start with 0. This level starts with 1, so we'll have to account for that. Yeah, probably just index plus 1 to account for that. Okay, so first let's figure out how many cans you can buy with the bonus. Okay, so starting cans, starting num of cans. Sometimes I just like to make long variables so I can keep track of everything. So that is going to be bonus minus price. JavaScript math can get wonky really fast. I think I want to use not parse int, math.float. Let me see. JavaScript math division. Oh, I misspelled that. Yeah. Okay, so I think it's yeah, I think it's math floor because we don't want decimals. We want a whole number. Okay. So that's going to do some rounding for us. And let me just make sure that math, let me make sure it rounds down. I mean, yeah, that it rounds down. So let me find a math object. Let me find floor. Okay, yeah, so it rounds down like we need. Okay, so I'm just gonna wrap this in a math.floor so that we're getting back a whole number. Okay, so that's our starting number of cans. All right, so now we need to do this loop. So would this be a while loop maybe? While okay, so we need a second variable to keep track of the number of cans remaining. And then I think we can use that in our while loop. So let num of cans remaining. And we're going to set that to starting. Initialize it to starting num of cans. And then while num of cans remaining is greater than 0. But what if we never get down to 0? We might need an additional flag. But for right now, let's just say while number of cans is greater than 0, while number of cans remaining is greater than 0, now we want to do this logic. Okay, so determine how many cans for the current. Okay, we want an index, right? Because while loops don't give us indexes. Okay, yeah, let's just make another. Let index equal 1. Okay, so the first thing is determine how many cans for the current level. So let cans num of cans needed of cans for level, that is going to be equal to index times index, so index squared. And then we're going to say if num of cans for level is less than or equal to num of cans remaining, we want to do two things. We want to so if the number of cans for the level is less than the number of cans remaining, we want to increase index. Oh, let me just change this to. We want to increase index is going to index is going to equal to index plus 1. And then we also want to change the number of cans remaining to minus the number of cans needed for the level. Number of cans for level is going to equal, number of cans remaining. Number of cans remaining is going to equal to number of cans remaining minus the number of cans for the level. Okay, so that is that. Okay. Now, if number of cans for level is equal to number of cans remaining, we don't want to increase the index because there's not going to be another level. That's basically the end. So else if num of cans for level is equal to num of cans remaining, num of cans remaining We're just going to set that equal to 0. Okay, and we're not going to change the index. So, okay, and so that will allow us to escape out of this while loop, because if number cans for level is less than number of cans remaining, then we can go ahead and decrease the number of cans remaining. If the number of cans for level is equal to the number of cans remaining, then we know after this we're not going to have any more cans remaining. So if number of cans is greater than, yeah. So that's another case. If we have 4 cans for the level, but we only have 3 cans remaining, what should happen then? So else if number of cans for level is greater than cans remaining, then well, can that ever happen? Yes, that can definitely happen. So in that case, we would want to break. Let me make sure we can actually break. Okay. Okay. So statement. Okay. I just want to make sure we can break. Wow. Okay, break statement terminates the current loop. Yeah, okay, so that's what we would want to do in that case. We would want to break out of this loop. Okay, that's like our escape hatch. So then we would finally want to return you know what? Okay. So I think I'm looking at this else statement and this first if statement, and I'm wondering if we actually do want to increase the index. Because for the case where you have just enough cans for this new level as what's remaining, and I think you do, because you're not, index isn't indicative of going through the cycle once again. It's just indicative of can this current level be achieved. And if you have a number of cans for the level equal to the number of cans remaining, then you can complete that level. So I'm going to go ahead and erase that else if statement. Okay, so the end result should be a number. So I think we can go ahead and return index, and that should be the solution. So let's see. Return index. So index represents the number of levels. Let's see if that works. Let's test it out. Oh no, that's not good. Whenever anything takes a while, and I have a while loop, I just assume there's some sort of infinite loop happening that's going to crash. Okay, yeah, so something timed out. Okay, well, at least it didn't crash on me. Okay. Is break not doing what I think it should be doing? Okay, so I think I need to think through index a bit more. All right, so let's say we have 4 cans that we can buy stuff with. 4 remaining cans. That's our starting point. So on level 1, number of cans remaining is 4. That is greater than 0. So number of cans for a level, so the first level is 1 times 1, so we need 1. So number of cans for level is 1. Is that less than number of cans remaining, which is 4? Yes. So we're going to say index is equal to index plus 1. Well, no. Okay, so I think this needs to come out. Right? Okay, so either way, number of cans remaining is going to equal to number of cans remaining minus number of cans for level. So that's going to be 4 minus 1, which is 3. So then it's going to come back through the loop, and index has now been set to 2. So cans for this level, 2 times 2, that's 4. Number of cans for level is 4. Is that less than the number of cans remaining, which is 3? No, so it's not going to go through this if statement. It's going to go through number of cans per level is greater than number of cans remaining, so it should be breaking. And it's not breaking, so should I just explicitly set number of cans to be 0? It's not semantic, but let's see. Okay, it's still taking forever, so let me remove this break. I'm not sure if that was right. Okay. Okay, so maybe this index. Okay, so I think we want the index to increase regardless. So I think maybe the index isn't increasing, so the number for levels isn't getting triggered correctly. So I'm going to move that out of any statement and see if that works. Okay, well, we got a whole bunch of failures. Expected 6 instead got 8. Expected 5 got 7. So it seems like it's always off by 2, almost. Okay, well, yeah, because now we have index is equal to index plus 1. Okay, so index is not being increased in the right spot. But when we had it just in the if statement, it was causing an infinite loop. Okay. I see. So, okay, so I do want this index happening up here, but I took out the case of when number of cans was, because remember I had that second if else statement for when number of cans per level was equal to number of cans remaining, but I didn't go back and update this operator to account for that. So I think now with less than or equal to, that should resolve it. Let's see. Okay. Okay, well, we're still getting all of these failures, but at least we're not timing out. So, okay. So we're always setting index equal to 1. Okay, so we need to actually set it equal to 0 because it's not guaranteed that you'll be able to hit level 0. So that's first mistake. So, we need to, okay. So I don't know if it'll be problems doing 0 times 0. Let's just try. Okay, so 0 times 0, it didn't cause anything crazy. But now we are consistently off by 1. Why is that? So we're saying so I'm looking at this first if statement. So if the number of cans for the level is less than or equal to the number of cans remaining, we want to do minus the number of cans from the number of cans for the level. So this index plus 1 business, so I mean, from the output of the test, expected 1 and got 2, expected 2 but got 3. It looks like you're not supposed to be adding it here, but okay, so let me talk through this in words for when should index increase. So if we have the cans for the level, then we know that completes that current index. So right here we're checking for 12, you need 144 cans if you're on level 12. You need 25 cans if you're on level 5. So that's the level times itself. Okay, so that's the number of cans needed for the level. Number of cans remaining needs to be subtracted from the number of cans for the level if you actually have the number of cans needed. If you have enough cans remaining for the current level, then you want to go ahead and do that math. And then the next time around, index needs to be increased. And I don't think it makes a difference if we're increasing the index in this if statement or out here. I would be very surprised if that mattered. Let's just test it out. Okay, yeah, so that does not matter. What matters is, okay, well, that actually did. That made our numbers even more off. Okay. So wild. Okay. So why isn't this working? I don't know if I've ever actually had to use a while loop in real life. Usually those are avoidable. Let's see. I don't think do well. Okay. Okay. We can say Okay, I'm going to change index to current level, just so things are clear. Okay, so current level achieved. Okay, so just because you have the number of cans for the level minus the remaining cans, like you have enough for the current level. But that does mean that you can go ahead and continue on. Okay, do we need another greater 0? I don't know, I'm just testing stuff out now. Oh no, that caused another loop. Infinite loop. Oops. Oopsie. Come on, timeout. Okay. Okay, so the other thing is maybe the starting number of cans is wrong. Because getting back to the original. Oh, what happened? Oh. Oops. Well, greater than 0. Alright, well, we know that it's going through these tests. So, expected 1, but instead it got 2. So let's just go through it with these numbers just to see if we can see what their problem is. So you have a $9 referral bonus, and beers cost $2. So you should be able to get 2, 4, 6, 8. You should be able to make 4 beers. Okay. So on the current level, okay. All right, so we're saying current level is 0, so 0 times 0. That's obviously going to just be 0. Okay. Number of cancer level is 0. Number of cans remaining is 4. So current level is going to increase by 1. Number of cans remaining, that's just going to be 4 minus 0. Okay. And then current level being 1, that's going to say 1 times 1. So number of cans per level, you need 1. How many do you have remaining? 4. 1 is less than or equal to 4. So now we're saying the current level is 2. But we actually don't know that yet. Okay. But current level has been changed to 2. But number of cans remaining. So you have number of cans remaining is still 4. Number of cans for a level is 1. So now you have 3 cans remaining. And then with the current level being 2, you have 2 times 2. So you need 4 cans for this next level. And you have 3 cans remaining. So, but you incremented the level in the last iteration. So current level is now 2, but it really should only be 1. Okay, I see. Okay, so it is a problem with this logic. So 1, current level should start off as 1. Or should it? Okay. Current level, it doesn't make sense to start off as 1. I mean, as 0. So you're saying current level times current level is 1. If the number of cans for the level is less than those remaining, it's right there. It's so close. Okay. Okay, I remember why I had current level at 0. Okay, so we first need to say I had current level at 0 because you're not guaranteed to make it to the next level. So I think we're being too optimistic with this +1. We need to drone down and say you only increase the current level after. Well, so this is, I was going to say you only increase the current level once you know for sure that the number of cans per level. Okay, so this number of cans per level is less than the number of cans remaining. That is only, okay. That means that you're good for the current level. But we need to actually look into the next level to see if you're good there too. So if level +1. Now, how do you do a square root in JavaScript? I do not know. Okay, so I just want to paste this in there while I have it. Okay, so we're going to say if the current level +1, if the next level, if it cans for the next level, okay. All right, let me make a new variable called num of cans for next level. For next level is going to equal this bad boy. And then we can say if num of cans for next level is less than or equal to num of cans remaining. Then we can go ahead and increment the current level. Okay. Yeah, so we only want to increment the current level if we know that the next level is okay. So I'm going to go ahead and attempt this, which will test it against more than these test cases. So let's just go ahead and see what that nets. Okay, it all passed. Excellent. I will include a link to this problem in the description. I solved it with JavaScript, but you can choose from these other languages. And then I'll also post a link to my solution. I'll clean it up a little bit, and that will also be down in the description. If this video is helpful for you, make sure you like it and make sure you're subscribed so you don't miss out on future videos. Thank you and have a good day.